Hi guys, all right, here we go, day 2, limits as x approaches c, the first day. So what we're going to do today is we're going to find the limit when we don't have a graph in front of us. I still can't believe I'm teaching you this. Not being in front of you is challenging for you, obviously, and for me as well. But we're going to do the best we can. So remember what a limit is. The limit of a function as x approaches some value is just the value that y approaches as we come from both directions. So let's just review a little bit what we did last time with the limit from a graph. Okay, so the first one is a two-sided limit because I'm asking you to find the limit of the function as x approaches 1. So that means we're going to come from both sides. So we want to get to x is 1, right? This is where we want to try and get. But we're coming from both sides. So when we come from the left, it's going to reach a y value of 1. And when we come from the right, it's going to reach a y value of 1. So the limit does exist. The limit is 1. Now this guy here is a one-sided limit because they want me to find the limit of the function, which really I'm just finding the y value again, as x approaches 2, but I'm coming from the left. So here's x is 2, and I'm going to come from the left. So as I come from the left, the y value is approaching 2. Let me erase some of this. Okay, the limit as x approaches 2 from the right. So here's x is 2 again. Oops. Here's 2. Right, now I'm going to come from the right. So as I come from the right, I can see that the y value is 3. So hopefully now you guys notice that the next question says the limit as x approaches 2. So this does not exist because I got different values for when I approached from the left and when I approached from the right. So we can use the symbol, or you can say does not exist. And that's just a little recap of what we did last time. Okay, so now we're going to find the limits when we don't have a graph. All right, and the first ones are pretty basic here. Okay, so to find the limit, remember you're just finding the y value. As x approaches something, what is y approaching? So instead of having a limit of f of x, I'm now going to have some function there. So 3x. 3x is just a line, right? It's just a linear function. So it says substitute x equals a number into the function, and whatever that y value is the limit. So if I plug in 2, the limit is 6. And if you look at a graph it, graph y equals 3x, right? And if you want to find the limit as x approaches 2, when I approach from both sides, it is 6. Next one, same thing. You can just replace 5 right in. Remember what this graph looks like? That's it, just y equals x. Number 3, same thing, just plug 5 in. So 5 squared minus 4 times 5 plus 3, and we get 8. And this is just a parabola. And at x equals 5, if we approach from both sides, we do get the same answer, 8. Okay, what if it's a constant? Well, remember what a constant looks like. So this really is just y equals 5. So if I were to look at y equals 5 on a graph, it would look like this. So at any x value, 1, 2, it doesn't matter what the x value is, it's still going to be 2 no matter if I approach from the left or the right. I mean, not 2, it's going to be 5. So it says the limit of a constant function, y equals k, at any point is just that value. So same thing here. It doesn't matter what it is. This is a constant. So the answer is just pi. And again, you could look at the graph. Okay, so now for some more fun ones. So we're going to go back to rational functions. Remember the unit where we graphed the vertical asymptote, the horizontal asymptote, and we would find holes. So it relates back to that. So we're going to find the limit of these rational functions. Now there's 3 different things that can happen well, three common ones. We might have to factor, we might have to simplify, we might have to rationalize, and I'll show you why. So we're going to start out the same way like we just did on the previous couple questions. I'm going to take this 3 and I'm going to replace it in. So if I replace in, if I replace in 3, I wind up with 3 squared is 9, minus 9, I get 0 on the top, and 3 minus 3 is 0 on the bottom. If you get 0 over 0, this means that there's a hole in the graph. But just because there's a hole in the graph doesn't mean that the limit doesn't exist, right? So we could have a hole in the graph like this, but as I approach from the left and as I approach from the right, I'm still going to approach the same y value, so the limit does still exist. So here's what we do when you wind up with this special situation, and the whole lesson today, this is what's going to happen. We're going to wind up with 0 over 0 as we sub in, and we still want to be able to find that limit. So all you're going to do is factor and cancel. So we have dots on top. You have dots, right the bottom. Reduce it, and I'm left with x plus 3. Now take your value and sub it into the simplified version, and that's your limit. And you should remember doing that with the rational functions. Remember, I would always tell you to first simplify it, right? And then use the simplified version for the rest of the work we would do, and that's how we would find the coordinates of the hole. Remember that? So we would simplify, and then you would plug the x value into the simplified version. So this is all related. Okay, what happens here? Well, same thing. I want you to have a procedure down. Your procedure is always going to be to plug in this value at first. Maybe we'll get lucky, and we will have an answer. So 1/4 minus 1/4 over 4 minus 4, but we can see here it happens again. We get 0 over 0. So if we get 0 over 0, it means there's a hole. So we're just going to simplify and then, plug in. But we can't factor this one, but I'm sure that you guys notice that this one is top bottom. That was my kitty cat jumping on the table, if you heard him. All right, 1 over x minus 1/4, and then the bottom is just x minus 4. Okay, so remember we want to get an LCD, so the LCD would be 4x, so I'll multiply by 4. Whatever I do to the bottom, I have to do to the top to maintain equivalency. I'll multiply by x, I'll multiply by x. So we have 4 minus x over 4x. Okay, so now we're going to, remember top bottom, we're going to keep the top and multiply by the reciprocal of the bottom. Remember this, make it look pretty. So this becomes 1 over x minus 4. Now on day 1 in the review in this unit, remember I reviewed right here that that's the -1 rule. So I'm left with -1 over 4x. Once you're simplified, now we go back. Now we go back and take that value and plug it in. So we have -1 over 4 times 4, so 16. So the limit, as x approaches 4 for that function, is -1 over 16. Okay, so we saw so far when you plug in and you get 0 over 0, you can factor, right, and then simplify and plug in. Or we can simplify a complex fraction with top bottom. And all we're doing is just like rewriting it to look a little different so that we're able to produce some y value. Okay, and now let's try this one. So on that first day with review, we rationalized the denominator, and then I also showed you that sometimes we might rationalize the numerator. So here's a reason why we might need to rationalize the numerator. Let's plug in 9. And look, we get 0 over 0 again. So what does that mean? It means there's a hole. So we need to somehow manipulate this function so that I can plug in and get some sort of y value, which will be the limit. Okay, so let's rationalize the numerator. I like to put parentheses around all binomials. Okay, so the top is going to be dots, so I'll take the first one and square it. I'll take the second one and square it, and I'll put a minus sign between it. The bottom, remember on day one, I said just leave it, don't FOIL it out, because some nice stuff happens here. Right, look, goodbye to you guys. Be careful, because the rad x plus 3 is on the bottom, so this is 1 over rad x plus 3. Now let's take our 9 and sub it in, and that'll be our limit. So 1 over the square root of 9 plus 3, so 1 over 6. And there's my limit. Okay, next one is just a fact. So if we want to find the limit of the sum or difference or product of a function, we can actually separate it. So for instance, in this first one, if I want to find the limit of f of x plus 7, I could just take 2, plug it in, and you're left with 17. But you can also separate it. So I could find the limit of f of x plus the limit of 7. So remember, same thing, plug it in. We get 10 plus, and now this is the limit of a constant. This is really y equals 7. Right, so at any x value, right, any x value, it's going to be that constant of 7. And then we can see 17 equals 17. Okay, so that's just a little fact. All right, let's do some more. Okay, hopefully you're liking this. And let me give you an overview again. When I want to find the limit of a rational function, you're just going to start out right away by plugging in whatever this value is. And hopefully we get lucky and we get an answer. If we don't and we get 0 over 0, then we're going to somehow try to simplify it, rationalize it, so that we can plug in and get an answer. Okay, so let's plug in 2. So 2 squared minus 4 over 2 minus 2. So there it is again, 0 over 0. That means that there's a hole. But just because there's a hole doesn't mean that a limit doesn't exist. Again, like I showed you before, you could have something like this, and just because there's a hole doesn't mean that the limit doesn't exist when I approach from both sides. Okay, so dots on top. Okay, there's the classic sounds of my animals. Reduce, I'm left with x plus 2. Now take your x value, sub it in, and my limit is 4. Okay, hopefully you're somewhat liking this, not so bad. Next one, plug in again. So 1/3 minus 1/3 over 3 minus 3, 0 over 0. A hole exists. When we have a hole, somehow simplify, rationalize, do something to alter it so that we can replace in the value and get the limit. Okay, so top, bottom over here. And we're just practicing the ones that I just taught you on the previous page. LCD is going to be 3x, so I'll multiply by 3. Multiply by x. So 3 minus x over 3x. Top, bottom, keep the top. Multiply by the reciprocal of the bottom. Sorry, these pens. And then we should notice again -1 rule. So -1 over 3x. Now plug in your 3. And my final answer is -1 over, I'll just write this so nobody gets lost, -1/9. Okay, looking good? Hopefully you like it. I'm so sad that I'm not there teaching it to you. All right. Okay, next. Okay, so this guy looks a little different, but let's plug in 0. So 2 plus 0 squared minus 4 over 0. Again, there it is, 0 over 0. This whole lesson today is 0 over 0. Tomorrow's lesson, when we plug in, it's going to be c over 0. So it's important that you recognize this 0 over 0. All right, so what are we gonna do? So I gave you a little hint here. We should probably expand out this guy right here, right? So let's FOIL. Okay, so we're just gonna FOIL the top, right? So if we do that, we're gonna have 4 plus 2h plus 2h plus h squared, and then don't forget that minus 4. Combine like terms on top. So those guys go together, and then hopefully you notice that these guys wipe out. So we have 4h plus h squared over h, and then you can either take out a GCF, you can divide. I'll take out the GCF. Reduce, and now take your x value, well in this case h, sub it in, and now our limit is 4. Okay, so I have in my notes that number 10 is on test. Okay, so important one there. Remember, I will be giving you a test on this, and you know it will count. So, but you know it'll be everything that I've taught you, nothing different. Okay, so 11 is for you to try on your own. You can pause it, go ahead and do it, and then when you're ready, rejoin me. Okay, so plug in as usual. We do get 0 over 0. Again, a whole. Just because there's a whole doesn't mean that a limit doesn't exist. Let's do a little top bottom. So how'd you do on this? The LCD for this is XA, right? Or AX, doesn't matter. So multiply by A, multiply by A, multiply by X, multiply by X. So A minus X over AX. And top bottom, keep the top, multiply by the reciprocal of the bottom. And there it is again, -1 rule. So we're left with -1 over AX. And now they wanted us to sub in A. So -1 over A times A. So -1 over A squared is my answer. All right, so hopefully somebody got that right. Okay, we got 2 left. Let's do it. I'm gonna go like this so I have some space because this one has a lot of work. Let's get a pretty color. We will use this nice purple. Okay, so we start out the same way. Let's put in 0. So square root of 2x minus the square root of 2x over 0. So surprise, 0 over 0. There's a whole again. All right, so do we notice that this is a rationalizing question? So we're going to carefully do this. We're going to multiply by the conjugate, 2x plus h, plus rad 2x over rad 2x plus h plus rad 2x. Look, remember, when we're doing the conjugate, right, you're doing the opposite sign. Okay, so I'm gonna go up here. Oops, that's crazy. I'm gonna go up here for that work. Let's find my purple pen again. Okay, so when I'm gonna do dots right here, take the first one and square it. So that's just 2x plus h, right? The radical sign's gone. Take the second one and square it, right? So rad 2x squared is just 2x, minus sign between them. So that's our top, and now what does our bottom look like? So our bottom is h times this. So h times rad 2x plus h plus rad 2x. Okay, so what's happening now? Well, on top, these guys are wiping out, right? So goodbye to you guys. So I'll just write the steps so nobody gets lost. Okay, and then we can see we can simplify here. Our h's are gone, so we're left with 1 over rad 2x plus h plus, rad 2x and now we're just going to replace in 0. Okay, so here's my 0. I'm going to replace it in right here. And I'm going to replace it in, oopsie, nope, you're not replacing it in anywhere there. Okay, so we're left with 1 over rad 2x plus rad 2x. How many rad 2x's do you have? You have 2 rad 2x's. So 1 over 2 rad 2x. So maybe you rewatch the video and you do that question over again. Okay, because that's a goodie. All right, we got one left. Okay, so if the limit, this is a substitution question. It says if the limit of f of x as x approaches a is 5, so I'm giving you the answer to this one, and the limit for g of x as x approaches a is -4, I'm giving you the answers, then I want you to find the limit as x approaches a of f of x minus 3 times g of x. Okay, so look, it's just substitution. So f of x is 5, so you're going to put a 5 in right here. Minus 3, and then g of x is -4, so you put a -4 in there. Oh, I forgot to switch markers. Okay, so we're left with 17. All right, guys. So, you know, I really want to give you Delta homework so that I can, like, keep track that you're doing it. But I did not plan on giving you Delta homework. I planned on giving you, like, dittos that I have that, you know, completely match the lesson. So I'm going to give you these, I'm going to give you the dittos instead. It's page 15 to 16. You know, it's the next 2 pages in the packet. And then I think I'm going to put on Google Classroom where, like, you have to upload the work to me. Like, you have to take pictures that you did it with your name on it, and you have to upload that to me. So I think that's what I'm going to have set up, but I'm not going to have that set up until Monday. Today is Saturday right now, but I'm just trying to get a little bit ahead. Okay? So for now, I'm sure you guys, most of you probably know how to do that anyway. I just have to learn how to do it, but my daughter's going to teach me how to put in a request for you guys to do that. Okay, that's it. If you're watching this now, which is Saturday, I hope you get to enjoy your day a little bit. Okay, stay positive, stay healthy, and I'm hoping I will see you guys all again. All right, bye.